Hello, I hope you are fine. Today let's talk about the inaccessible in curves. So this is a question paper that was done early this term, the July series for 2024. So we had a question about the curves and inaccessibility, and I'm going to show you how we can tackle it easy and simple. So today, here with me, so this is a lecturer from Matili Technical Institute, Gadgira Steven. I'll be taking you through the simple calculation. Feel free to ask any question on the comment or the email provided on the profile. I'll be able to assist you further on any clarification. So we go directly to the question. So here, so this is the first question. Two straights ABC and CDE are tangents to a proposed circular curve of radius 1750 meters. The lengths AB and ED each of 1150 meters. So those are the two lengths there. So the intersection point is inaccessible, but the angle at B and D can be measured. So these are the angles. So angle A BD is 137.48 minutes, and then angle BDE 146.12, and the length BD is 1437 meters. So calculate the distances from A and E to the tangent points on the respective straights. And then the second question, the deflection angle for the first subcode, the standard code, and the last subcode. If the change of B is 2530.85 meters and 20 meter standard code that were used through the change basis. So here is a total of 20 marks that we can tackle. So this is a simple question. So first of all, we are going to tackle the first A, then later we are going to do for B. So this is just simple. I've done many calculations related to such. So we have 2022 July series question and many more. You can go to the playlist and further seek clarification. So I've done at least 3 more questions. Total of 4 questions are related to the inaccessibility found in curves. So let's go directly and we translate what we have been given. So A, here we have A, C, E. So point B, D, we find those points here in the middle. So point C is inaccessible. That's why we have been provided this angle. So this angle here and also this angle here. So these were found on the question paper. You can go back and check. And then we were told A to B, we have 1150 on the question. So remember to, so here we have been given A, AB and ED. So they are the same, 1150. Those are the data given. So A to B the same, so D to E the same. So we have been given to calculate the points, so the distances from A and E to the tangent points. So our tangent points remain as, so this is the first point of tangency, this is the second point of tangency, or the last point of tangency. So these are the points that we are in reference to. So we are supposed to calculate the distance from A to T1 and E to T2. So first of all, we need to calculate the distances. So we have here the tangent. The tangent is the point from where the point of tangency begins to where our intersection point is, so that the tangent length, the same is done. So from C to T2, so we calculate the tangent length. After calculating the tangent's length, we go ahead, we calculate the distance B. to C and C to D. So here we'll have gotten these two points. By subtraction, we subtract and we get the remainder, of which will be from T1 to B. Given from A to B is 1150. We'll subtract what we have from first point of tangency to B. So let's go directly to the questions. So first of all, we need to calculate the angle. So here we subtract the angle in order for us to get the angle. So by subtracting 180 degrees to this angle found here, you will get your angle found there. Then the same will be done. So by minusing 180 degrees, so angles on a straight line add up to 180 degrees. So by having that 137.48, we subtract 180, we'll have gotten the angle that remains. The same is done. So by subtracting 180 to 146.12, we'll have gotten the internal angles found here on these triangles. So those internal angles will first of all help us to calculate the angle of deflection. We were never given the angle of deflection nor the angle of intersection. So by calculating these two, we'll have gotten the angle of intersection. Then again, we get the angle of deflection. So we can move in either way. So you can remember the addition of two alternate angles will be equal also to the deflection angle found there. So this is the simple calculation in which we are calculating. So here we go. So simple. So 180 minus that, we get the angles. So these two are the angles found inside the triangle there in which we have. So these two are the angles where we will be using. So those two, by addition of those two angles, will get our angle. So the total of those two angles found here and here will be 76. At 76 we can get it directly. That will be the deflection angle, and also we can subtract 180. So angles found within the triangle add up to 180 degrees. So by subtracting 180 to it, we'll have gotten the angle of intersection found here. So this will be the angle of intersection found on this point there. So again, by minusing 180 degrees angle on a straight line, so we'll have gotten the deflection angle. So it's just simple repetition. So our deflection angle becomes 76 degrees. So that is the deflection angle. By the formula, tangent length is equals to r tan theta over 2. R we had been given on the question, that is 1750 tan 76 divided by 2. So by use of a calculator, remember here it's a half of 76 before you do the tan. So remember that. So by doing that, we'll have gotten the tangent length equal to 1367.2 meters. So that is the distance covered from T1 to C on the diagram here. So T1 to C, this distance from T1 to C, that is the tangent length. The same thing from C to T2, that is the tangent length also. So our answer remains the same. So that is the tangent length calculated there. So that tangent length will going to be used it by calculating the next things that we are going to tackle here. The distance DC is equals to, so this is the sine rule, something small, I'm sure you are familiar with it. So A over sine A is equals to C over sine C. Going back to this diagram here, so these are my small, so here we have a small a, small b, small c. So by having, so this is simple, or even at the alternate angle. So this is just a simple formula. I am sure you tackled it from high school, maybe even from the lower levels of primary. So by having sine A, so the opposite, so the angle that we had here will be what we'll be using, the same. Sine B will be the angle here. So sine C will be equal to the angle of intersection. Yeah, simple like that. So by the use of a calculator, sine A over the angle is equals to C. This is the distance covered, so the distance covered there, distance covered here 1437 is equals to over sine the angle of intersection. So by the use of a calculator, correctly use of a calculator please, I will have gotten our distance A as 994.81 meters. So the same thing by calculating the distance BC. So these distances are here, so by calculating the distance BC and CD, so those are the points that we are looking for. After getting these 2 points, we can be able to get the distance covered from T1 to B and also from D to T2. So those are what we are calculating. So but for now we are calculating the distance B to C, C to D by the use of this sine rule. So the same thing is done by the use of a calculator. That distance covered there, so this distance B, so you correct there, so distance B is equals to 5, so that distance is equals to 823 point, let me erase some, so 823.87. so this is the distance covered, so you remember to correct that. So the distance covered there, that will be equal to B. You remember to correct that so that it can be easily seen. So that distance is equals to what we have there, and again we can observe that the calculation is easy, and by the use of a calculator you can do wonders. So the distances that we have gotten are the same distances on which we were supposed to calculate earlier, and by calculating those distances I will have gotten what we have here. So this is A and here we have B. We move ahead, so we need to subtract the distances that we have, so T to B and D to T2. So by having that distance from the tangent, so we have the tangent, here's the distance covered by the tangent, here is the distance that we have gotten now. So by subtracting those two, I'll be able to get the distance covered from T1 to B. After getting the distance covered from T1 to B, this is the first point of tangency T1. That distance also I will subtract it from the total distance given to us on the equation, that is the distance covered from A to B, and I'll have gotten my answer, which will be the distance of A to the first point of tangency. That is what the question is looking. The same thing will be done on this other side. So by having the tangent length, we subtract the distance which we have calculated now here B. I'll have gotten the distance covered from D to T2, after which I'll subtract the distance given to us the question, and by subtracting that distance was D to E, I'll have gotten my distance T2 to E. Simple. So that's how you finish that calculation. So here is a little representation in case I have been going a little bit faster for you to catch up. So this is just the simple. So T1 to B is equals to, so T1 to C that we have calculated minus BC, so this distance also we have calculated. Then our answer, so the distance T1 to B will be 543.38 meters, which also will have to subtract that distance. So A to T1, this is the distance, so BC that we had been given on the question minus the answer that we have gotten now earlier. So the distance from A to T1 is 606.62. Again, the distance T. So these are the distance that we are calculating. So distance T2 to D is equals to T2C, which we have calculated, minus CD, that there, by subtracting that we have 372.44 meters. Again, that answer we subtract by the value that we had been given earlier on the question, and we'll get so this is the distance here. We'll get the distance from E to T2 as 777.5 meters. So those are the distance that we are supposed to calculate. Come observe this simple diagram. Everything is illustrated well here. So by the use of subtraction and getting the distances, minusing the distances, finally we can get our simple answer. So you remember that is how we can do simple calculations, in which you can do at least something better, something simple, and which you can better your understanding of the curves. So inaccessibility in curves can be done that way. So by doing that, we move on to the next question, that was B, and that question, so the deflection angle for the first subchord, standard chord, and the last chord, if the chain edge at B. So here we had been given the chain edge at B, not the chain edge at intersection, but the chain edge at point B. Then the standard chord is 20 meters. So that is the chain edge that is used. So the standard chord of 20 meters. So we come again. So chain edge at B is 2530.85 meters. So that, remember, so that's chain edge at B. First of all, let us look at this question, this diagram. So here we have been given the chain edge at B here. That means in order for me to get chain edge at A, I'll need to subtract this small distance here, that is distance T1 to B, and we have calculated that distance. So on these questions we have already calculated that distance of T1 to B, and we have understood it well, where we get those distances. So by the use of simple calculations calculator, the chain edge will be given that. So the first chain edge, that's where T1 is, that's the first point of tangency, is equals to chain edge at B minus the distance covered from T1 to B. So that distance was 606.62. So chain edge at T1 is equals to 1924.18 meters. So by the use of the formula that I always use in order to calculate the remaining distance covered in order for me to get the chord, so I divide it by 20. I have 96 full chains. By multiplying, I'll get the full chains covered a distance of 1920 meters. That means the distance that remained to be covered was 4.18 meters. So this is the distance that remains to be covered in order for us to reach where T1 is, and here we are using full chains of 20 meters. That means the first chord, I'll have to subtract 20 from that distance remaining there. So my C1, that is the first subchord, will be 15.8 meters. Then again the standard chords remain as usual. They will be the full chords, which equals to the chain edge, that is the 20 meter chain. And then our last chord is equals to the curve length remaining divided by the number of chain edges. So one chain equals to 20 meters. That's how we'll get. So the curve length, here is equals to 76, which is the deflection angle, multiplied by theta multiplied by r, that is we had been given, over 180 degrees. We get the total of, so this is the total of 2321.29 meters. This is the curve length. So by subtracting the distance which we had already gotten, that is 15.82 meters, we'll get the remaining distance covered on the curve as 2305.47. Again, we divide it by the full chords and I'll get 115 full chords. The remainder which we'll have gotten by multiplying the full chords minus what we have, what we were remaining here with it. So I'll get the last subchord as 5.47. so this C Cn minus 1. So this C1, here we can have C2 until all these full chords end. Then the last chord, which is the last subchord, is 5.47 meters. After getting that, we finally come to the formula which we use. Our final formula is so the deflection angle, the first subchord is equals to 1718.87 multiplied by, so this C1 over the R, that is 1750 multiplied by 60. So that's a little conversion. Our deflection angle will be 1532. So the same is done. So the C, this is the full chord. Here we have 20, and then the last subchord, here we have 5.47. So this is our answer. So these are all the deflection angle, the first, the full, and the last subchord. Thank you. So I will be looking forward to more questions given to us by Nick and also by the coming SIDAC examination. So I'm sure a repetition of such will be highly in the near future. Thank you. That will be all, and we'll see each other when you have another question. Thank you.